All right, so another thing that we need to just practice problems, if we're taking a look at this for Chapter 5, practice problems, deals with electron configurations and orbital diagrams. So I guess if we're going to write that down, electron configurations and orbital diagrams. Certainly a significant bit of information. The way I think about it, and I would hope you would as well, is to think about the periodic table. So again, here's my very rough periodic table, and I know that the S block is over here, the P block is over here, the D block is here, and the F block is there. The next thing I recognize is, what do they start counting at? The S starts counting at 1. So 1, 2, etc. going down. The P's start counting at 2. The D's start counting at 3. And the F's start counting at 4. If you know that, then basically you should be able to follow the flow, starting from number 1, hydrogen, and go knowing that helium is also part of the 1s, but go all the way through the 6d. So that's kind of the basis of that. Now, if I want to do an electron configuration versus an orbital diagram, we know that the electron configuration is a way of writing it all out, 1s with the exponents, 2, etc. The orbital diagrams may have dashes or boxes, and you fill those in with arrows. So let's do an electron configuration. And I'm going to look over to my periodic table here, and let's choose one like Mercury. Mercury is number 80. So it has 80 protons. Let's do the electron configuration for that. Well, it's going to start 1s2. That takes care of the hydrogen and helium. 2s2 takes care of lithium, and we're basically now at lithium and beryllium, 3, 4, 2s2. 2p6. So again, I've taken care of this. Then I went to here. Then I'm now going through the top over here. After 2p6, 3s2. Then 3p6. Then 4s2. Notice again, we now are over here with numbers 19 and 20, potassium and calcium. Then we get into the 3d10, taking care of all the 3ds. 4p6. That would be after the 3D, we're now at the 4p, 4p6. Then 5s2. After the 5s2, we're just at the 4d10. And again, we were going through here, we're kind of going through. Then we're at the 5p6. After 5p6, 6s2. And after 6s2, that's cesium and barium, number 55 and 56, we then go down. So after here, we go down to the 4F14. I know there's 14 because I know that an F has 7 in it, which means maximum of 14. 14. Then we come back up from here, back up in here, which is going to be your 5D. And your 5D actually is the row that the mercury is in. It's the furthest one over. So I could count across if I wanted, or I could just know, hey, it's the last one. It's going to end 5d10. Okay? Now, obviously, if you were given this electron configuration, you can much more easily determine what it is by just looking at the last one. There is an abbreviation. We will talk about the abbreviation, but not now. So 5d10, I could just simply look to my periodic table and say to myself, self 5D. Okay, D is in the middle. It starts with 3, so 3, 4, 5. It's the third row down, 10, the 10th one over. So that's why it's Mercury. Okay, that's electron configurations. Orbital diagrams, I'm not going to do one that's as long, but let's go ahead and take a look at one. Let's say we want to do the orbital diagram of gallium. Gallium is number 31. It's in the P block, and we can go from there. So, orbital diagram, we're going the energy from the lowest to the highest, and really, we're just going to start with the 1s and keep going kind of across like we did in the electron configuration, except for we're going up. 1s, 2s, 2p, 3s, 3p, 4s. After the 4s is the 3d, and then the 4p. And that takes care of where I need to be for gallium. 1s, 2s, 3s, 4s. All s's have one dash, only one orbital. P's all have 3. 1, 2, 3. So the 2p, 3p, and 4p, all with 3 orbitals. The D has 5. 1, 2, 3, 4, 5. And now I can just fill in my arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You guys are bored watching me count, but basically these would all be full. Okay, and again, notice Hund's rule, I am going across and then coming back if I need to, of course. And then now I end for P1, and this would be the orbital diagram for gallium.